Hello, welcome to the second part of atmospheric circulation. This is week 6. Today I will talk about first the meridional picture of atmospheric circulation in more detail, and then we will look at the full 3D world. So let me draw a little diagram here. We consider height on our vertical axis, so this will be altitude, and then we have latitude on our horizontal axis, and the altitude goes from 0 to 15 kilometers, and we will focus just on the northern hemisphere. So we'll say here's the equator, 30 degrees north, 60 degrees north, 90 degrees north. So this is 0 degrees, and this is the North Pole. Now, what we've learned is that there's a lot of surface heating happening at the equator, and air is rising, and you actually, as a result, get a lot of clouds and condensation and precipitation in this region here. So these are typically cumulonimbus clouds, and the predominant direction of convection here is rising until the air is no longer buoyant, and that's where we hit the tropical tropopause. And you can imagine, because the hottest region is near the equator, that's where you have the most upward buoyancy of your air, and so the tropopause is actually highest near the equator, and then it sort of drops off and reaches around 7 kilometers at the pole and around 15 kilometers at the equator. And what I've drawn here, this upward rising air at the equator, is the southernmost part of the Hadley cell, and then the air gets deflected to the north, and then it gets cool and drops down at about 30 degrees in the mid-latitudes, and then as it travels across, it gets warmer again. And this is what's called the Hadley cell. This region here at the equator is known as the intertropical convergence zone, or short ITZC. What's next? Here at the mid-latitudes we have a second cell known as the Ferrel cell, cold sinking air, and then rising at around 60 degrees. And here we have the mid-latitude tropopause. And the region around 60 north is actually characterized by the polar front. And at the top of the polar front you have the polar jet stream. And then north of 60 you have the polar cell. Here's the polar tropopause, and here you have the polar cell. Again, warm air rising and cool air dropping. So when we look at the full picture, we will need to consider the pressure at these different latitudes. And wherever you have rising air, you will get low pressure, and then you have high pressure where the air descends. And that will determine in what direction your wind blows. So we will see that between 0 and 30 you have the northeastern trade winds. Here you'll have the westerlies, warm southwesterlies, and then again easterlies between 60 North and the North Pole. And in the next video we'll look at how this translates to zonal winds